In this lesson, we're going to look at classifying and graphing polynomials. So the equation that we're given for polynomials help give us some insight as to some of the main characteristics and properties of the graph. So we're going to look at how to classify them first. And we classify polynomials in two ways. One is by the degree of the polynomial. And so we always look at the highest exponent in order to determine the degree. If the exponent is 0, which means this is an equation like f of x equals 5, that is a constant, and this shape would just be a horizontal line at whatever that numerical value is. If the degree is 1, that would be like f of x equals 3x. Anything with x to the first power would be linear. Those are like y equals mx plus b, all of those formulas. And that would be a straight line. Anything, if x squared is the highest, that's going to be quadratic, which is this curve here. It kind of looks like a cup. And remember, if that is negative, it's going to face down. If the exponent is x to the third, that is a cubic polynomial, and it is going to kind of have this S curve sort of feel to it. Now, beyond this point, we only have to classify x to the fourth and x to the fifth. But just so you know, all of the even exponents, so from 2 to 4 to 6, so x squared, x to the fourth, x to the sixth, that graph just becomes more compressed this way. And the same thing for 3, 5, 7, and so on, x to the third, x to the fifth, x to the seventh, it just becomes compressed from left to right. And the x to the fourth is quartic, and x to the fifth is quintic. Okay, that's the first way. The second term that we use when we're classifying is how many terms there are in that polynomial. So if there's only one term, it's a monomial regardless of what the exponent is. So here we're looking at how many of those terms do we have in between the pluses and minuses. So if there isn't a plus or minus anything, it's just 3x squared. That is a monomial. As soon as you say 3x squared plus something, then it becomes a binomial. And remember, we can add or subtract. So it could be 3x squared minus 5x. If we have 3 terms, it's a trinomial. And if we have 4 or more terms, it's a polynomial. So we would use both of those in order to classify. So when we classify a polynomial, we would have 2 words, and they would both come from our chart. So for example, if I gave you the polynomial, let's say just what we used before, 3x squared minus 5x, the highest degree is 2. So if we look at our chart, that is a quadratic. And we have 2 terms, so it is a binomial. So when they ask you to classify it, you would say it's a quadratic binomial. Okay, leading term. This is important because we're going to get some important information from our leading term. The main thing to remember with this is to put your polynomial in standard form. And standard form means your highest exponent down to your lowest, and you're going to go in descending order, okay? The leading coefficient is the number that is out front. So if we go back up and we look at this 3x squared, pick a different color, this is my leading coefficient. It has the highest exponent, okay? Or my leading term, sorry. My coefficient in front of it is 3. The reason that this term is important is because it tells us the end behavior going to the positive infinity and negative infinity directions. So if my leading coefficient is positive, then you can see this little arrow right here. That means on my graph, it is going to trend upwards and to the right on the right-hand side. If it is negative, it's going to trend down and to the left. Okay? End behavior to negative infinity is determined by the degree of the polynomial. So if we go back and we look at our diagram, notice that every even exponent polynomial is going to have both ends either going in the positive direction, or if it's a negative leading coefficient, it's going to go in the downward direction, but they're both going to go the same. So that means they're either both going up, or they might both be going down. We'll draw that over here so we don't get them confused. Okay. If it's odd, like 3, 5, 7, etc., then that means they're in opposite directions. So if to positive infinity, if it's up and to the right, then it would be going down and to the left for the negative infinity, and then vice versa over here. If it's down and to the right, then going to negative infinity, it would be the opposite direction. Okay, so this is all determined. So remember, this guy over here, this one over here is determined by that leading coefficient. If it's positive, it's going up. If it's negative, it's going down. And then the left side is determined by the degree. If it's even, it's going to be the same. If it's odd, it's going to be the opposite. Okay, we also have relative extrema. So these are our relative maximums and minimums. And this tells us where the graph is going to turn, basically. If you have a relative maximum, that is a high point in the graph, like this up here. Okay, and then if you have a relative minimum, that's going to be the low part of the graph. So if you can imagine this is the highest, that's where you're going to change from increasing to decreasing. And if it's the lowest, it's going to switch from decreasing to increasing. Okay, and then we can use those increasing and decreasing intervals from the graph. The main thing to remember with both of these is to follow the graph left to right. When we list our intervals, we're always asking, what does the graph do as we approach from the left to the right side?